Hello and welcome to section 1.1 with Math 7. Today our main question is, how do we add integers with the same sign? So the key there is that we are dealing with things that have the same sign, and signs we kind of leave for the idea of positive or negative. So just to give you a heads up on what we're looking at there. So same sign means we're either adding two things that are both positive or both negative. And then we can extend that to, start dealing with bigger and bigger sums, more and more things. Some things to remember, things like sum just means the answer to an addition problem. And integers are whole numbers that we're working with. So let's go ahead and get right into this. This would be a lot more fun in person, I would say, in the sense that if I had you in class, that we could actually pass out these counters and use them as positives or negatives. So what these usually are just little kind of plastic coins. One side's yellow, the other side's red. And when using those, it's pretty commonplace to think of the yellow as a positive one and the red as a negative one. So for this problem here, we just have 3 plus 4. And the way we want to do that is we want to look at both of those pieces and what happens when we bring them all together. Okay, so that's kind of a common theme that I try to go with when I'm looking at addition, is I'm just looking at I have two things and I want to kind of mold them together and see what I get. So I kind of think of more of like a Play-Doh type of problem when I'm thinking of this. I have these two quantities of Play-Doh and I want to mush them together and I want to see how big they get. So for the first one, we have 3 positive counters, and the second one I have 4 counters. So how many counters are there in total? 1, 2, 3, 4, 5, 6, 7. So we have 7 total counters. And it says here, what is the sum and how do you find it? Well, the sum is 7. And we found that by counting. It wouldn't have to be always how you do it, but the way we did it is that we counted the total number of counters. Okay, and in this instance, they were all positive counters since they were all yellow. So we come up with a positive 7. Another way you could write that is you could write it with a positive sign, but as you probably know by now, we rarely add just a random positive sign in front of positive numbers. It's more like kind of that innocent until proven guilty. They're all positive numbers until we say that they're negative numbers. Okay. So for the next one, it says negative 5 plus negative 3, or kind of the way I think of it is I have negative 5 and I have negative 3, so how many do I have total? So first of all, how many counters are there? Just total number of counters, 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 total counters. And since the counters are all negative numbers, what happens when we add this negative 5 and negative 3? They're all negative ones. You can't see that on there. That was smart. They're all negative ones. Every single one of these represents the number negative 1. So when I add negative 1 together 8 times, I get negative 8. A question on this says, when adding two numbers with the same sign, what sign do you use for their sum? So this kind of brings me to something that they're trying to get us to see in these two problems. And so what happens when in both of these we had the same sign? So what we really did is we added the numbers and then we dealt with whether they were positive or negative. So we just took 3 and 4, or we took 5 and 3 in the second one, and we put those numbers together to see how many total things we had, and since they were the same sign, we just kept that sign. Okay, so if we have same signs and we're adding, we want to keep the sign. We want to add the two numbers and keep the sign. All right, so when adding two numbers with the same sign, what sign do you use for them? I would say the same sign, or what I would really think of as, I would say, to keep the sign. Okay, keep the sign. The next Explore activity looks at adding on a number line, which is a great skill. It's a great way to look at things. And it says here, just as you can add positive integers on a number line, you can also add negative. So what they mean by that is, if we look at that problem that we had before, 3 plus 4, and I'm going to look at a horizontal number line just not to, to not take up very much room. 0, 1, 2, 3, and I can keep going. The idea with adding on a number line is, this first number tells me where I start. I start at 3. And then I want to grow this by 4. 1, 2, 3, 4. And where do I end up? Okay, this was 4. This is 5. This is 6. And this is 7. So I end up at 7. Okay, and that's the idea of adding numbers on a number line. Those ones are positive numbers. This example is going to go through some negative numbers. So it says here the temperature was 2 degrees Fahrenheit below 0. And then the temperature drops by 5 degrees. What is the temperature now? So what is how do we write 2 degrees below 0? Well, on a number line, or how do I write that as an integer? I would write that as negative 2 degrees. And you could say, negative 2 degrees Fahrenheit if you wanted to. They're just looking at how do I write it as an integer. So then I want to mark that initial temperature on the number line. I'm going to put a point at negative 2. A drop in temperature of 5 degrees is like adding negative 5 to the temperature. So that's kind of a big jump there, but we do understand that going down degrees is like becoming more negative. Okay, so count the number and mark the final temperature. So we want to go down 5 degrees. 1, 2, 3, 4, 5 degrees. Okay. What is the temperature written as an integer? Well, what's between negative 6 and negative 8? That's going to be negative 7. So it's negative 7 degrees, or negative 7 written as an integer. But then you got to think that then we would have the line here, right? The line on the thermometer would be right here. None of that stuff would be there. In fact, I could color that in. I don't want to take all the time to do that, but you kind of get the picture here. And I know you can't do this. You can't exactly write with a white pen. So, I don't expect you to do this in your books, but this is what the thermometer would look like after that drop in temperature. So the way we would say it in words is that we would say that the temperature is 7 degrees Fahrenheit below 0. Right? It's still not above 0. We didn't go upwards on the number line or on the thermometer. We went downwards. So it's 7 degrees below 0. So a couple questions that kind of go back on that same idea. Suppose the temperature is negative 1 degree Fahrenheit and it drops by 3 degrees Fahrenheit. Explain how you would use the number line to find the new temperature. I think that you could go ahead and pause the video right now and fill in something. I don't necessarily need to know the answer. I want to know how you would get it. Okay. Hopefully you pause the video and write something, not just wait for that little bit of time. So again, this is an explanation problem. It's not come up with the answer. I know that we could all come up with the answer using the same process that we just did. So what I would say here to explain it is that we start at -1 on the number line. Then we would move downwards, move down 3 spaces, or lines, or however you want to think of that. We want to move down 3 marks. That's what we want to do. Okay. Again, that was an explanation problem, so we want to follow directions. Okay. So we want to explain how we did it. That's how we did it. It never said what is the answer. Okay. So communicating mathematical ideas. So this again, more communication, and that's a pretty common theme with what we do. We try to focus a little bit less on calculations, especially at the start, and a little bit more on how to do it. So it says here, how would using a number line to find the sum 2 plus 5 be different from using a number line to find the sum -2 plus -5? Well, for the first one, sometimes I'm bad at switching colors and I need people to remind me, but you can't remind me when you're just watching a video. But to remind you how to use a number line to find 2 plus 5, we start off at 2 and we go over 5. So this is 5 spaces and we'd land at 7. How would it be different from, how would that be different than using -2 and -5? Well, the difference would be is that we would start at -2, and yes, this one I did horizontally, the other one I did vertically, so I don't really care which way you say. There's 2 right ways and 2 wrong ways to say that you would move. I'm going to say I'm going to start at -2 and move negatively, and by that I either mean on the vertical number line you would move down. On my number line I would move left. Right and up would be incorrect answers, but down and left would be the right answers. Move negatively 5 spaces. Okay, can you think of 2 other negative integers, 2 other negative numbers that have the same sum as -2 and -5? If I start at -2 and I move, let's just go ahead and say that I move, start at, so here's 0, here's -2, and I move left 5 spaces, there's probably another way that I could do that. For instance, I could start at, instead of starting at -2 and moving 5 spaces, I can start at -3 and move how far? Hopefully you're saying 4 spaces. So I would say -3 and -4. And there's a bunch of other, well, not a bunch because they did say negative integers. So, there's a lot of other opportunities there. So now we want to look at more of a mathematical way to do it, or more of a practical way when you don't have the time to draw a number line every time, or the numbers are just frankly too big that we, drawing a number line is almost obsolete. It's almost like I'd spend more time making an accurate number line than I would doing anything else. And just to let you know, there's a lot of times that I'll think of things as a number line, but I won't make it like to scale. I'll say, like this one, I want to go -7 plus -6. I might just think of, here's 0, here's -7, and I want to go back 6 spaces. So a lot of times that's kind of how I'm doing it visually, or mentally I should say, as opposed to drawing every little hash mark on a number line. But let's look at another way that we can get this done. So in this first one we have -7 plus -6. And they talk about finding the absolute values of the numbers. And absolute value is always a positive number, or 0. It's technically the distance between that number and 0. So you always think of it in a positive sense. Basically, we're dropping the negative signs. So then I just think about adding 7 and 6, and I get 13. And then remember before, on the first page, we said when they have the same sign, you keep the sign. Well, they both have negative signs, so I keep the sign to give me -13. Okay. So here's a couple reflection problems on this. It says, does the commutative property of addition apply when you add two negative integers? And explain. I'm going to jump us to that really quick and just think about it. Would -7 plus -6, does that equal, I'll put a little question mark there, does that equal -6 plus, I'm going to put the -7 in parentheses too, because there's really no reason not to. Does that equal the same thing? If we go through this same process, drop the negatives, and then we're thinking 6 plus 7, which is still 13, and I keep the negative sign. -13, so I get the same thing. So does it apply? Yes, it applies. You just want to make sure that you keep the signs with their numbers. Okay. All right, critical thinking, it says choose any two negative integers. So go ahead and choose two. Maybe write them off to the side. I'm thinking negative integers. I want to get a little crazy here. We're going to go -37 and -54. Those are my two. Don't choose the same two. That's not creative. Is the sum of the integers less than or greater than the value of either of the integers? So remember, less than really just means more left on a number line. And so greater than just means more right. On a number line. I'm not going to write that again, but that's really what it means. Less than means farther to the left, and again, this is a horizontal number line, but it means farther to the left, farther away from 0. That kind of works in this case. So when I add those two together, when I think about, in my case, -37 plus negative, and we like to put that second one in parentheses, just so we don't mix up whether we're whether we're adding a negative or subtracting it, kind of a ghost positive. That's why they do that, because they're afraid that this looks weird. You see what operation is really happening here. The reason we put that 54 and that negative 54 in parentheses is that so we know it's addition happening, not subtraction. You'll find that when I write negative signs, I typically kind of write them a little more towards the top of the number, and that helps me know that that's just a negative sign and not a subtraction sign. They don't really mean a whole lot of different things. They pretty much mean the same thing, but they do look different. So when I do that, and I'm thinking about it, but I haven't sold myself to actually find that sum yet, but we will in a second. But when I do that, is that going to be less than or greater than all these, either of these numbers, or both of these numbers, I guess, is kind of the better way to say that. Well, when I actually do that, again, I strip off the negatives and I add the numbers together. 37 and 54 is 80, 91. That's hard to read, I'm sorry. And it's actually negative 91. And is negative 91 greater than or less than these two numbers? Well, it's less than. It's farther to the left on a number line. It's more negative. It made a number that's more negative. Sorry, farther to the left. My camera's reversed, so your left is that way. Okay, so it's more to the left on the number line. Okay, is that going to be true every single time if I choose negative integers? So if I choose negative numbers, is that always going to be true? And yes, it is. For that same idea that I just said, we're making the number, or the answer, more negative. I'm going to put that in quotations, more negative. So we're making it go farther to the left. All right, and what we'll end with today are these your turn problems. If you want to pause the video and work through them, that would probably be the best. And I'll talk about them in just a second. Okay, so for each one of these, I'm going to strip the signs off if they have them. I'm going to add the numbers and keep the sign. So negative 8 and negative 1 turns into 8 and 1. 8 plus 1 is 9. And I keep the sign. Both of these are negative. Oh, let's go to 8, I guess. Both of these are negative. Strip those negatives off. 3 plus 7 is 10. And keep the sign. For number 9, both of these are negative. Strip those off. Add the numbers. I get 60. And keep the sign. Same thing here. They're both negative. Strip them off. Add them. 32 and 38, that's 70, and keep the sign. 109 and 191 are both positive, so I don't strip any sign off, I just add them, and I keep them a positive. So that's going to be to 300. Negative 40 and negative 105, both negative, strip that off, I get 145. And keep the sign. These are both negative, so I strip those off, add them together, and I get 1,650, and I keep the sign. Strip the sign off, 200 and 800 is 1,000, and I keep the sign. So hopefully that works out for you. Make sure that you do the reflection problems. And we will see you in class. Bring any other questions that you have to class. ask them right off the bat. I will open up a time to answer questions, and we'll try to get to the bottom of this. All right? Have a good day. We'll see you in class.